Hey guys, time for another video, and this one is about my discovery project, and that is my search for the ultimate 4-inch long-range drone. And I did two videos about this project already. One was about my thoughts on it, the second one was about the design, and now I got all the parts together and it's time to build it. And I will share with you all the parts that I chose for my build, the electronics, why I chose them, and how I soldered everything together. And I'm just taking you along the journey to come from just the parts to this, the built thing. And if you're interested in that, then stay tuned. And on this channel, I'm sharing with you my projects and the designs that I do for them. My name is Nick, and this is how I fly. Here we are, welcome to my bench. These are all the parts that I'm going to be using on this build, and I'm going to walk you through them right now. First of all, we have the flight control, which is the Hamsu all-in-one board, which is a board that I really like because it has everything in, it's really all-in-one board because it has the ESCs, a 4-in-1 ESC, and the flight control in one board, has enough MOSFETs to stay secure up to an amp rating of 30 amps, which is quite amazing. I'm not going to be using that, but you know, still it's good to have. It also has lots of UARTs that are available through the pads here on this side. I already had this one built in, so these are already soldered. And it also has a black box recording and all of that, so I think this is a really great board. And most importantly, it does have a 20x20 mounting pattern, which is very helpful. A friendly warning from Future Nick here. I now have 5 of these boards, and 2 out of 5 were actually dead on arrival. And with just a little bit of quality assurance, this could have been prohibited. So Hamsu, sorry, but you're doing a bad job here. And to all of you, if you want to buy this board, be aware that this can be an issue. Then for the motors, I have the Zing, iFlight Zing 1404 3800 kV. I'm using these because I have been using the Emax Eco 1404 with 3700 kV on my previous build of the micro long range, and they were performing pretty well, and these should perform very similar, but they just look much nicer, and this is why I want to be using these. And also what I do before I plan my build, I make a list of all the parts that I'm going to be using, which I'll be showing you on the side here, and I check the weight of these parts, and then I enter these numbers in a tool like eCalc to get information about what thrust weight ratio I can expect, if the amp draw is within the limits that I need, also to see how much the battery has to provide, and all of that. And these numbers look very okay to me. The C rating is going to be a little bit higher than what the battery can ideally provide, but I'm not going to be pushing this too hard with this build. This is a long-range drone. This is not going to be a freestyle drone or a racer. It will be possible to do some freestyling with it, but just to get nice video shots when you do long-range, because what I like to do is, fly from down in the valley up on a hill or so, and then fly back down, surf back down the mountain, stuff like that. And that's just a little freestyle is necessary here. All right, then video. It's going to be a CATX Vista. I don't think I need to say much about that. I'm going to use it with the case here because long range, I just don't want to take any chances at all. Then for the GPS, I'm going to use a Byton BN180 GPS. Also, I don't think I need to talk much about it because it's well known and much used. And then for the RX connection, I'm going to be using a Team Black Sheep Crossfire Nano RX with a Immortal T antenna, the normal sized antenna. It's just, I like the Crossfire set, and this provides good reception for a long distance. And then there is the frame. I am using the parts that I designed. Check out my design video if you're interested in how I came up with the design and details about that. These are the arms and these are the other parts. They come with a a different set of carbon because I had everything cut from CNC Madness, but then I made some late minute changes, and that's why I had some parts cut from a friend of mine. So these are a bit different. Also, I am using the bike chain bolts based on the design that Dave C came up with for his mini long range. The only difference is that the bike chain bolts that you need to mount everything need to be shorter in height compared to the ones that are used on the mini long range. Like this is one from the mini long range, and you see that these are longer, and that is mainly because or only because the arms that I use are going to be 3 millimeters, and the upper and the lower plate have 1 millimeter, or these now have 1.5 millimeters. I still need to see which one I'm going to be using, but for now I'm going to go with the 1.5 millimeter, and that means you have the 3 millimeters plus 2 times the 1.5 millimeters, which is 6 millimeters, and the one that come with the mini long range, if you get the stuff cut from CNC Madness, they have a minimum height of 6.5. So this is not going to be able, you're not going to be able to tighten down this with these. So you have to get lower ones. And the ones I have here have a lowest height of 4.5 millimeters, if I recall correctly. So these are going to be working just fine. All right, and then we have the CNC, not the CNC, the 3D printed parts. I used a nice yellow color because I got the TPU donated from a friend of mine, and he got the yellow color, and I actually like the yellow color very much because it has a nice contrast with the black carbon. And here is, so this is the 3D printed part for the camera. The Cadex Vista camera comes in between here, and up here you can mount a naked GoPro or whatever GoPro you like. And this is the mount for the GPS. The mount for the Cadex Vista camera, I printed this a little slim. I also have a version at hand that is a little bit thicker, which will be more stable. But then again, when the camera is in between here, it's going to provide additional stability, and I think that's going to be enough, and it will save some weight. So I will try to go with this. All right. Anyway, these are the parts that I'm going to be using, and now I'm going to start by, well, putting the frame together. So I'm going to fast forward to when that's done, and then let's take a look at that. I just realized I'm going to be using a few additional M2 6mm screws to mount the spacer bolts. Oh, and apart from the spacer bolts, just to give you a quick update what hardware I'm going to be using here, that is M2 times 4mm screws for the motors. These are 14mm spacer bolts that I'm going to be using for mounting the top plate. Like I said, the difference of my design, also with the 5-inch mini long range from Dave C, is that I'm having this one plate design, so all the distances are identical, and that means you just need one set of spacer bolts, which are in my case M2 14mm long ones. All right. Yeah, and apart from that, for mounting the Cadex Vista, I'm going to be using nylon bolts and nuts because, you know, you don't need to have metal here, and nylon is just lighter, and some rubber mounts that come with like any flight controller nowadays. It's just a little piece of rubber, and this is used to put a little bit of distance between the board, the plate, and the Cadex Vista. All right, now let's mount the spacer bolts. Oh, come on. There we go. I usually push these in and then use some solid object to push them through. That's it. That's the first one. All right. So let's put this in as well. All right, and then let's do the same for the GPS mount in the back. So that's that. Now let's mount these to the frame. right, now the back. Now let's mount the top plate. All right, the frame is together. This is the Discovery frame. Quick introduction, this is the Discovery frame. It is, I think, the best combination of the mini and micro long range. It is a 4-inch version of the mini long range from Dave C, which is basically 5-inch, and I made some adjustments for the 3D printed part in the front, for the lower and upper plates, so you can mount everything in here in a very slim way. Yeah, all the 3D printed parts are different, and yeah, the center pour is also very different. So basically the only thing I kept is the mounting and the arms. That's basically it. And the arms in a shortened way. So that's it. Let's continue. Okay, so what I'm going to do next, I am going to install the flight control and then solder the motors to it. Oh, good lord. Now, when I was about to mount the motors, I realized something that didn't occur to me before, and that is the motor mounting pattern of these arms. These are like, I took the arms from the mini long range design, and they were made for the Brother Hobby motors. The mounting pattern expects 12 millimeter, but I want to mount the Zing 1404 motors, and they have a 9mm motor pattern, and that is a problem because like I cannot mount these on these arms. Well, luckily you are within a time machine, so I already have different arms because I redesigned them. I already uploaded them to Thingiverse, so you can find the updated version there. And here I changed the holes to like these longer holes. So now you can mount both kinds of motors. You can mount the bigger Brother Hobby style motors, or you can mount the smaller, like the Zing with 9mm motor distance. All right, so for me, that was annoying, but that is usually the case when I'm designing a new frame, especially when putting everything together, things are just coming up. And this cost me another few days, but for you, it did not. So let's continue. So motors are mounted, that's the next step. And now I'm gonna tape down the cables and cut them to length and then solder them to the ESC/flight control here. Alright, so we got the motors soldered to the ESC, and what I'm going to be doing now is to solder in the voltage connector, which is going to go in here, and I'm roughly checking like where I'm going to position it, and the length that I cut has been keeping that in mind. So it goes in here, and then you wrap it around up here, and then comes the connector from the battery from the front. This is how I usually mount my batteries. You can do it through the back or somewhere else, depending on whatever you like. This is how I do it because, like, if the propellers are on here, this is the area where there is the most space. So I'm going to put this connector here on the side, and maybe on the other side there's going to come the beeper or so. So we'll see, but that's it for now. When I soldered it, I made sure that I still have enough space for the Cadex Vista to go in here. Because if you just mount them straight down, you're going to have some spacing issues. But this way it's going to connect nicely, and I still have enough cable to go up here. So that's fine. Alright, so that was the power cable. What I'm going to be doing next is I will install the Cadex Vista and solder that to the board. I'll show you the connection diagram in a second. And then comes the receiver and the GPS. Opening the Cadex Vista for the first time, always an exciting moment. Let's talk about how the electronics are going to be connected to the flight control, and I am going to be using RX1 and TX1 on the right side for the Cadex Vista, Below, TX2 and RX2 are going to be used to connect the GPS, because there is a 5-volt connection and ground right next to it, and this is going to be fine for the GPS module, because it works from like 3.0 volts, the lowest, up to 5.5 volts, so 4.5 is going to be perfectly fine. And then I'm going to connect the receiver to RX and TX3 on the top, because I do have a 5-volt connection right next to it, and TBS says that 5 volts is the best, so we're going to be using that. Alright, so now I'm going to connect the Cadex Vista. I will like cut cables to the right length and then connect these to the board. So let's do that now. Now let's mount the Cadex Vista to the lower board with the polyamide or nylon screws, and that's just going to take a second. Now to the... okay, let's see. We have TX here on the right side, and that needs to go to RX from the board. So the Cadex Vista is now connected. Next up is the GPS. It's the Byton BN180, and it goes in here. And from here, we are going to connect it to the flight control using RX and TX2. Gonna go around the right side with this. So with the Byton, we have ground on the side, and then comes TX, RX, and voltage. We are gonna connect TX and RX first. So TX of the GPS goes to RX from the board, and TX goes to RX. And then, as I said, we're gonna get voltage from the 4.5 volt pad and ground right next to it. Okay, as usual, because I had it upside down, I switched RX and TX, and that's not gonna work. So redo, redo, redo. Now we soldered the Cadex Vista, the GPS, and the only thing that's missing now is the Crossfire Nano. And this comes up here, so that's easy to solder. And the idea is to have it... yeah, where should we put it? This is a good question. Up here, there isn't much space there to put it, so that's going to be a very pushed down and not too nice way. What we could also do is put it underneath here. Yeah, this is what I'm going to be doing. Put it underneath here, and then it has enough space, and you can mount the antenna nicely here. So, all right, let's do this. Okay, and this goes here. I will use a little bit of tape. I was just thinking about where to mount the beeper, and I really couldn't come up with a good solution. That's always a problem that I find, but I wish I could incorporate this into the frame design somehow, but there really isn't a nice way to do that, because making the whole frame longer just for the beeper doesn't really feel right, because you never know what kind of beeper people want to use. Anyway, so I think I will mount it here. That's also why I left a little bit more space from the cables here, so I have contact with the carbon. And I think I will just mount it here this way, so it's not going to be in the way of the propellers. I can easily reach the button to deactivate it, because as you know, beepers are going to get very annoying. And yeah, that's what I'm going to be doing. But I want to activate the Cadex Vista now, and something that I want to do beforehand is to mount the antenna. Alright, now this still looks like an exploded kitten or something, but actually everything is soldered up now and in place, and yeah. It's time to put the camera mount in and the top plate, and then go over to Betaflight and do all in the configurator and do all the configuration stuff. All right, now this is it. This is it. We got everything in a nice little form factor. Let me zoom out a little because this is gonna look better this way. Yeah, we got everything mounted. We got the motors in, we got the motors connected to the flight control, we got the CADX Vista in. It really is a tight fit with the 14mm spacer bolts, but it works. It's not bent in any way, the top plate or anything. Like you can see it from the other side better. And that is actually because back here, there comes the little bolt from the antenna, and I put that underneath. This shifts like the back part a little upwards, but in my case, that's very much appreciated. Actually, you could also put this on top of the main plate, but I will just keep it the way that it is right now. And this makes sure that everything has still enough space and nothing is squished down. I think the total footprint is very small, which is nice. Oh, I can see that I still haven't put in the mounting screws for the flight control. I need to do that. But apart from that, this is been put together. Now I have to put on the propellers and configure in Betaflight. But I'm going to fast forward to that, and then we are good to go for our maiden. So I hope this was helpful and this is interesting if you ever want to build your own, and also if you want to just build any 4-inch long-range drone, because like the things that you do are not dependent on the frame too much, so you get the general idea, which I hope was interesting. And now, of course, the big question is, how does it fly? And in order to demonstrate this, I dug up a video that I did soon after the first maiden. This was all still with the standard settings, just to give you an idea how it flies and how it feels to fly it. And I have been doing lots of flights with it in the meantime, and I will probably share some more in the future, but I'm a bit hesitant with showing long-range videos because the legal gray area that we're in, and I just don't want to get into any trouble, and that's why I probably am not going to share too many long-range videos here, sadly. But still, I hope you will enjoy this video here, and yeah, if you like the stuff that I do, it would be amazing if you would just subscribe to my channel and maybe even click on the little bell icon on the bottom, so you'll get informed when a new video comes up. And until then, happy flights and see you again soon. So we're out here at one of my favorite spots to fly when I'm in the area. The landscape is just beautiful. There are not many people around, so you can just fly peacefully and without interruption. And yeah, here I'm just getting my bearings. I'm out here with a few friends of mine. That's always best. And it also is working in Corona times because you are outside and not too close to each other, so everything is fine. Yeah, I'm now just flying around a little bit with a low altitude, just getting a feeling for the quad. Right now everything is still on stock settings, so yeah, there's still room for tuning, of course, but for a 4-inch this already flies pretty stable, and I feel confident to go further with it. And I'm now just trying to get in a little distance, see how everything works out. I think in one quick flight before that I already did test the GPS rescue, which is something that I always do when I fly out a little further out. Yeah, so I got some distance now. I'm going over a hill, so I need to get some altitude so the video won't drop away. And yeah, so now I'm just flying and cruising, and actually this is something that I really enjoy the most, just cruising around. Here it's just skipped a little bit forward. This is something what I really love with these long-range quads, to just, just look around, study the area, and enjoy nature and then what this beautiful earth has to offer. And when you're a little higher, you have a great view. You can see, cities in the back, some towers and stuff. And I really just enjoy that. It's really peaceful, it's calm, and it's something that you need after a long week of work, or at least I do. Yeah, so now I'm a bit higher. There was a bit of wind that day, but as you see, this is a 4-inch drone. This is not a 1.5 kilograms 7-inch beast with two 6S lithium ion packs, but instead it is a 4-inch long-range drone. I'm using here a 3-cell lithium ion pack that I soldered myself, and I got flight times of around 18 minutes or 18 to 20 minutes without a GoPro, and with the GoPro naked it was around 15 minutes. So that's really nice. And that was already it. Now back to the landing, and yeah, looking forward for future flights, and I would love it if you would join me. So yeah, until then, take care, have a good time, bye bye.